This is Maths Academia and I am the Bless. You have reached the home of Maths. Maths is a subject of rules, and once again, rules. To do well in Maths, you need these rules at the back of your head. And to do that, you need to come back to these videos as much as you can. Please like, subscribe, and hit that notification bell. Now let's do cycle geometry. So cycle geometry is said to be one of the difficult topics in mathematics. Many learners face a challenge with cycle geometry and Euclidean geometry entirely, especially in grade 12. So what you need to do in cycle geometry is that you need to know all your theorems coming from cycle geometry from grade 11. Then grade 9, all those triangle rules, line rules, and all other quadrilaterals, parallelogram, and the rest. Then you also need your grade 12. In grade 12, they simply add similarity, proportion, and Pythagoras. Then when you approach the question, that statement on top of the question is the game changer. That statement tells you what you need to do. It reminds you of the theorems you're supposed to use. Examiner will use keywords such as produced, cyclic quad, center, tangent, diameter. When examiner uses those keywords, he's trying to remind you that there are theorems which are related to the center. Now when you read, you pause at center and recall your theorems. Then you check your theorems on the diagram and you can go to the question. But then you cannot treat the question if you do not know the rules. So you need these rules at any time of the day. Now let's see, produced. When examiner says produced, what does it imply? When a line is produced outside the cycle, we cannot solve it using cycle geometry theorems because it's outside the cycle. So we go back to grade 9. We use our lines, exterior angle of a triangle, exterior angle of a cyclic quad, and then we can use sum of triangles, exterior angle of a triangle as well, to get any angle inside the triangle. And to get the lines, we can use isosceles triangle, equilateral, and so forth. So in this case, when examiner says produced, you must go to your grade 9. And your grade 9, you've got supplementary angles, vertical opposite, and then also parallel. When examiner says the lines are parallel, it's a keyword. We have three things on parallel. We've got alternating, corresponding, and cointerior. We use mostly alternating and corresponding. The cointerior is very unlikely, but if the needs arises, we make use of it. And then on your triangles, you'll have sum of angles in a triangle. If the triangle has a 90 degree, you'll have Pythagoras, and you'll also have trig ratios. Then there's also exterior angle of a triangle. This one is very useful. In most cases, it's there. You must always look for it. And then you got congruency. We can use congruency to prove that two triangles are congruent. It means that they can both fit into each other. They are equal in angles. They are equal in sides. And then properties of quadrilaterals. The square, the rhombus, parallelogram, and so forth. You need to know those in case examiner says ABCD is a parallelogram. We'll have to know that opposite sides are parallel. Then in grade 12 now, we do similarity, Pythagoras, and proportionality. Let's start with grade 12 and we'll work backwards. We'll work backwards to grade 11 and 9. So grade 12, similarity. All that similarity says is that two triangles are similar if the angles are equal. If all corresponding angles are equal, the two triangles are similar. So we need AAA, three angles equal. Let's say this angle is X, it's equal to that angle, and then this one is Y, it's equal to this angle Y, and that one is Z, it's equal to this angle. If that condition is there in two triangles, the two triangles are similar because the corresponding angles are equal. So now what is a corresponding angle? Now let's name the triangles ABCD, ABC, and then DEF. And then we'll name this side B, this side C, that side A. And then this side will be E, small letter E, this side will be small letter D, small letter F. Then this angle is the corresponding X, corresponding Y, and corresponding Y, then corresponding Z and Z. And what you should make is that 1, 2. Always when we use similarity, you must choose your first reference triangle. Then you can go to the second one. If you choose an angle from first, you go to second. The next one, first to second. Never vice versa, first to second, and then you do second to first. You always use one way of doing it. 1 to 2, never 2 to 1. So in this case, a corresponding side is a side opposite equal angles. So X is equals to X, and then opposite. These two are corresponding, which means in these two triangles, B is corresponding with E. Then that's supposed to give us a proportion. Similarity goes further to say that if two triangles are similar, the corresponding sides are in proportion. So the corresponding sides are in proportion, which means the next corresponding side, you go to an angle opposite, and then on the next triangle, angle, the opposite side is the corresponding. So two sides corresponding to angle Z is C and F. And then the other two sides left corresponding to Y. So these are the sides opposite to Y. It's A corresponds to D. So in that case, when we have found our corresponding sides, we can get a ratio. Then the ratio goes like that. B from 1 to 2. From 1 to 2, never 2 to 1. You never mix. If you're doing 2 to 1, it must always be like that. You never mix. Then B over E. The proportion will be that B over E is equals to C over F, which is also equals to A over D. That is the proportion. The proportion, now we can see from the proportion that all the numerators come from the first triangles and all the denominators come from the second triangle. You must always make sure that they correspond in that way. If on numerators we have 2 that come from triangle 1 and then 1 that comes from triangle 2, the proportion is wrong. So they must always be from one angle. And then that is similarity in summary. Those are the rules of similarity. If two triangles are similar, the proportion is equal. Then how then do you use this similarity? How do you use similarity? We use similarity to solve for angles and also to solve for sides. In most cases, to solve for sides. Then now let's go to Pythagoras. Pythagoras in grade 9. We have Pythagoras from grade 9 and advanced in grade 12. So in grade 9 is the basic Pythagoras that has hypotenuse, adjacent, and opposite, and then a 90-degree angle inside the triangle. So Pythagoras says in grade 9, hypotenuse squared is equals to opposite squared plus adjacent squared. And then opposite squared is equals to hypotenuse squared minus adjacent squared. And also for adjacent, we subtract on the hypotenuse. So in grade 12, Pythagoras goes on and adjusts the grade 11 Pythagoras theorem. He adds into the triangle. So the basic right-angled triangle, we'll name this one triangle ABC, is the original Pythagoras. The original Pythagoras in grade 9. So in grade 12, Pythagoras adds a line here which is perpendicular to the hypotenuse. And then they will name it D. So Pythagoras goes on and says AB squared. AB squared is equals to AD times AC. AD times AC. So I like to memorize this by saying that AB or any side is going to multiply by the closest side multiplied by the hypotenuse. The closest side multiplied by the hypotenuse. Then from there, Pythagoras says BC squared is equals to, BC is this one. It's equals to the closest side, which is DC, times the hypotenuse. The hypotenuse AC. So the hypotenuse is common in Pythagoras. The change is the closest side. Then the next expressed side is the middle side. The middle side is expressed to say that BD is equals to AD times DC. So this last side does not have hypotenuse on the multiplication. BD squared is equals to AD times DC. It does not have the hypotenuse. It has pieces of the hypotenuse. And those three rules are the most important rules of Pythagoras. Those are the conclusions that Pythagoras expresses in grade 12. And then now let's go to proportionality and see what proportionality has for us. Proportionality is a whole new theorem in grade 12. It's a whole new theorem, but very simple. We have done it in mathematics without knowing that we're doing proportion. Proportion just means a side compared to another. As simple as that. We have been comparing things using division. So let's name this line ABC. Proportion says now that AB can be expressed in terms of BC and AC. And BC can also be expressed in terms of AC and AB. So now let's say the distance from A to B. AB is equals to 3x and BC is 8x. So altogether, this line altogether, AC is equals to 11x. AB is equals to 3x, that's a proportion. BC is equals to 8x, and altogether AC is equals to 11x. This is the sum. So this is proportion. You must take care here, there's proportion and there is units. The proportion and units, two different things. Do not make a mistake of mixing proportion and units. Proportion and units is two different things. Units is a measure of AB and proportion is AB in terms of something. So then how can we express AB in terms of BC and AC? So AB with proportion, it says that AB is equals to, we can say by distance it's equals to the whole side AC minus AB. That is AC is 11x minus 8x, and that will give us 3x. So in exam condition, they will not give all these values. They will give one or two values, and then you have to find the other in terms of the given two. So with understanding of that, that is just a basic proportion, expressing a side in terms of the other. Now let's go to the real proportionality theorem. The proportionality theorem uses a triangle, and we'll name this triangle ABC. Then on the triangle, they add a line in between, which is parallel to the baseline. And we'll name this one D and E. Then proportionality theorem says AD over A over DB is equals to AE over EC. AD over DB is equals to AE over CE. That is proportion. That is proportion number 1. So it's division. We've been doing division ever since the start of mathematics. So now it's just made in expression of other sides. So the triangle says that every division you can make on the left, it's equal to every division on the right in proportion, not in measurement, not in units, but proportion. So you must make note of that and never mix the two, units and proportion. So the units can be different, but then the proportion on the left and the right is the same. And then we can also express in another terms, any terms we want. We can say AD over AB, it's equals to AE over EC. So all you need to do, back to similarity, when you choose your side, you must make sure that on the denominators, you are choosing a corresponding side. On the numerators as well, you are choosing a corresponding side. If you check on AD and AE, AD and AE, they are corresponding. AD is right there and AE is right there. They are corresponding sides. This angle is equal to this angle because of parallel lines corresponding. So in this case, we can prove similarity on this triangle and the bigger triangle. And then this angle corresponds with that one, this one corresponds with that one. So this angle is opposite to that side, so it also corresponds to that side. You must make sure of the corresponding sides. If on the numerators you have AD, on the other end, you cannot go there and put EC for an example. EC will be down here, it's not corresponding. So they must always be corresponding. And then from there we can make another expression. We can make another expression and say that DB over AB is equals to EC over AC. And we can make another more expressions, unlimited expression, as long as your numerators, they are corresponding and your denominators are corresponding. You are allowed to make any other proportion on this theorem. And now done with grade 12 cycle geometry, grade 12 Euclidean geometry in sense, Euclidean geometry, and the whole of cycle geometry is grade 11. Grade 12 only adds 3 things: proportionality, Pythagoras, and similarity. But you can find that inside the cycle. So if you find it inside the cycle, you simply use grade 12 rules. And then you must watch out for your grade 11 rules. They contribute a lot also. So in grade 11, we have the keywords I've talked about. Produced. Whenever you see produced, you must look for grade 9 concepts. And then let's say now, and then the next theorem you need to look for is exterior angle of a cyclic quad. When it's produced, when a line is produced, it means that on the quadrilateral, the line is not ending at that angle. It extends over. The moment it extends, it creates an exterior angle. So that exterior angle can be of a quad or a triangle. And then now examiner says cyclic quad. If examiner says cyclic quad on that statement in a question, that is a keyword. Examiner is reminding you of the theorems. There's no need to forget the theorems. Cyclic quad has 3 theorems. Opposite angles of a cyclic quad, they are supplementary, which means they add up to 180 degrees. And then we have exterior angle of the cyclic quad, which is equals to the interior opposite angle of the cyclic quad. And then we have angles on same segment. Angles on same segment, also called angles subtended by the same chord. And then next on, we have center. Anytime you hear the examiner says center, point M is the center of the cycle, you stop right there. You do not read further. You stop and go to your cycle, look for your theorems. So the theorems we find on center, there's a radius in center. Radius must be equal. The moment the radius are equal, they create an isosceles triangle. Isosceles triangle has base angles as equal. And then from there, the radius can be perpendicular to a tangent if we have got a tangent. And then you must look out for the diameter. If we have a diameter on the center, we have diameter subtends a 90-degree angle. And then from there, we can also have Pythagoras. On the center, we can have Pythagoras. If we have line drawn from center, perpendicular to the chord, bisecting the chord, that two triangles created, they create Pythagoras. Because there's a triangle with 90-degree angle, the moment you see that, it's Pythagoras or trig ratios. So in those two triangles, we can make use of Pythagoras and trig ratio to find the sides and the angles that examiner may ask of. And then the next keyword is tangent. When we see a tangent, we must think now, which theorems of tangents do I have? So the tangent is tangents from same chord. They are equal. The moment they are equal, they create an isosceles triangle once again, which has base angles equal. And then we've got tangent perpendicular to the radius. If you miss this one on keyword center, you can still find it on keyword tangent. And then we have tangent. The angle between the tangent and the chord is equal to the angle subtended by that chord, which is summarized as tan-chord theorem. Then when you read further, there's a chance that you bump into diameter. And then if you get diameter subtends a 90-degree angle. And then also, if we're told about a diameter, it's also a hint that we can look for a point. If there's a point on a diameter, it could be a center. And never make a mistake of making conclusions that the examiner did not state on that paragraph on top of the question. If the examiner does not say M is a center or A is center of the cycle, even if we can see that A is the center, we cannot conclude that it's the center unless we have valid proof, unless we can prove by a theorem that it's a center. But we cannot simply say it's a center without a reason. Everything you say in Euclidean geometry, there must be a valid reason, and the reason you find on your theorems. So on center, I forgot to mention angle at center. It's very common. It's very common, and people make a mistake of angle at center. The angle at center is equals to the angle, is double the angle at the circumference. So to find the angle at center, you go to the center. There will be, let's say, M, and then M1, M2, M3. You investigate all those angles. M1, you check M1. Now you check what subtends M1, and then that chord which subtends M1, if it subtends anything else, it creates an angle at center, double the angle at the circumference. And then you go to M2 also, you investigate M2. What chord subtends M2? And then if that chord subtends another angle, it creates an angle at center theorem. And also on M3, you do that. Now that's it for today. I hope you have enjoyed this lesson. Please remember to like, subscribe, and hit that notification bell to find more videos like this. Cheers.